Hello, Biology 230. The topic of this week's module is the chemistry of life. Tuskegee researchers are currently studying several diseases, namely lupus, cancer, and heart disease. My name is Dr. Russell, and I'm the chairman of the chemistry department. And 9 times out of 10, all of you that are watching this video are going to have to take my class at some point in your academic career. I study, I do cancer research. I also study organometallics as well as biofuels, converting biomass into biofuels. All right, today I'm going to illustrate to you how chemistry can be applied to real life. The structure that you see on the board here is a structure of glucose. Normally glucose is cyclic. In this case, it's what we call acyclic. And the way that glucose is used in chemistry as well as in medicine is that if you put a radioactive isotope onto glucose, you can use glucose to image different types of tumors and other types of disease. So here, this is glucose. If I react glucose with this fluorine-18 isotope, I generate a fluorine-18 isotope labeled glucose. Now, what's so important or special about this? Well, fluorine-18, the isotope itself is radioactive. It can be used as a radio tracer, and this fluorine-18 decays and gives off what's called positrons. Those positrons can be picked up by a PET scanner, a positron emission tomography scanner, and because disease cells metabolize glucose at a much more rapid or faster rate than normal cells, the cells that take up the isotope labeled glucose are able to be imaged, and a radiologist can read that image and actually tell whether or not disease has spread, in particular cancer. So a cancer cell would actually take this fluorine-18 radio-labeled isotope, it will pick that up, and then you'll be able to tell whether or not a particular type of cancer has metastasized. So the question is, how does this apply to real life? Well, my wife is a breast cancer survivor, and upon her initial diagnosis, she had to have a PET scan, and they actually injected her with a radio tracer. I don't know if it was this one, but something similar. And they also relied on this positron emission to pick up whether or not her tumor had actually metastasized to some other part of her body. Thank God that it didn't metastasize. So if you ever want to know how chemistry and biology are related, the two sciences are intertwined, and there's really no separation between them. We depend on one another. Chemists depend on biologists to do the assays, and biologists depend on chemists to come up with the compounds to run assays with.